Newton's law of universal gravitation states that any two objects in the universe attract each other with the fourth force, which is proportional to the product of their masses and inversely proportional to the square of their separation. And we can see it's been developed into this formula, where d is the distance between objects. If given the radius of objects, you can include that in the distance to the centre of mass. And g is the gravitational constant. And you can see that on data sheets, which is 6.67 times 10 to the minus 11. As an example of a problem you could see would be, what if the masses were doubled and the distance quadrupled. So we can get this equation, put our new values in, so doubled masses, 2m1, 2m2, divided by the distance 4, d, and then squared. And we'll get a value of 4 outside of g m1, m2, divided by 16 d squared, expanding that out. 4 on 16 is a quarter, so we'll have 1/4 outside of our original force. So the new force will be 1/4 the old force. And there's a variety of ways to ask questions about that formula. See, as we've seen, Newton's law of gravitation is very important in understanding how satellites orbit, the orbital motion of satellites, and used for calculating in the orbital motion of satellites. As we had the force, it's G1 m1 m2, on a distance or radius squared, and we let that equal to our circular motion, centripetal force, where V was 2 pi r on t. And we substitute that in, and we calculate and work it all the way back down, and we end up, as we've seen in a previous video, we get Kepler's law of periods. And this can be used to work out periods, radius, orbital motion, etc.